So good morning, and thank you very much to the sponsors and to the organizing group for inviting me to speak for a couple of minutes today on one of my passions, which is all things data science. So I've been doing data science for over 20 years before it was called data science. Back then it was just called maths or statistics or computer science or whatever you could cobble together into a job. But now it's called data science, or what we've seen the field subdivide even further. Now we have MLOps as well, and we keep, as the field keeps maturing. So today I'm going to talk about a new team that we've set up in Johnson & Johnson Consumer Health, which is the MLOps and data science team. And very much it's about the start of our journey on how we're trying to refocus and reshape the conversation around AI products versus data science projects. So I'm going to talk an awful lot about products. We're a CPG, we're a product-focused company. So I'm going to talk about very much data science and AI in terms of products versus projects. So you may or may not have heard, about this time last year, Johnson & Johnson announced it was going to spin off its consumer health division into a separate company, which last month was announced is going to be called Kenvue, starting in January next year. So the planned new consumer health company is about a $15 CPG, which is pretty exciting when you think about it. You get to set up a data science and an MLOps team in a $15 billion startup with 1.2 billion customers. So that brings its own challenges. And then Johnson & Johnson then will have a $77 billion company, which will have pharmaceuticals, medical devices, and so on and so forth. So if we look at the consumer health, we have the self-care, which would be pharmaceutical products. We have essential health then, which would be like Band-Aids, shampoos, Listerine, and then the skin health and beauty, which would be Neutrogena, Aveeno, products like that. So you're probably all very familiar. We're very much the face of Johnson & Johnson. This is what you see when you go into the shops, but we're very much the smallest part of Johnson & Johnson. So the biggest part, which would be pharmaceuticals, you would have, through COVID vaccines or medical devices, through hips and knees and things like that. So we're very much when people talk about Johnson & Johnson, it's Band-Aids and things like that. So that's us. So we're separating out next year. So today I'm going to talk a lot about products. And I like this quote from Seth Godin, who's a serial entrepreneur and an author. And don't find customers for your products, find products for your customers. Now I know Steve Jobs would say, how does the customer know what they want if you haven't given it to them yet? But generally in data science, a lot of data science seems to die on the grapevine, where you say, we will build it and they will come. Because when we talk about customers, we generally talk about internal customers. If we're going to create data science models, we're trying to sell it internally. We're not trying to sell it externally to customers on the high street. We're trying to sell it internally to marketing departments or sales departments. And it's not as easy to sell to them as it is on the high street, because they're more pessimistic and they've got bonuses and targets and all that kind of stuff. And they're not just going to jump in and say, hey, you've given us this great data science model, we'll take two of them. So when you talk about product focus, it's very much product with internal stakeholders and internal customers versus external. So, as with any journey, about 6 months ago, I took on this role. So I've been with J&J for 7 years. I've worked in different parts in J&J. And I would say that data science and consumer health is relatively immature. It's relatively new. And it's gone through the classic cycle of, we've lots of data science models that don't scale. Data scientists are leaving because they don't want to support models that don't scale. And all of a sudden you have a lot of interest, but no products. So you've a lot of research. Now the data scientists would say, no, these are products, and I would say, no, they're not, because you're after losing the person that made it run, because it took 20 hours of their time, where it should really be a fully automated process. So it's not really a product, it's data science on steroids. So very much, the majority of the journey in the last 6 months was really changing the narrative, changing the conversation around, okay, well, what is data science? What is engineering? What is an AI product? So instead of talking about project focused, talk about product focused. So as with anything, there was no team in place. So the first thing was to go and hire people. And this was a challenge because I was told I had to hire the people in the US. So if you actually did a search on LinkedIn, we did a search on LinkedIn in April during the year for MLOps and data science professionals in the US. And out of 250 million people in the US, however many million people working in tech in the US, there was about 2,500 names came up on LinkedIn for the US. So you can see if you actually go looking for the unicorn to have somebody that understands data science and understands MLOps and so on and so forth, that number gets really small really fast. Particularly earlier on in the year, people wanted to work in tech. Now we're seeing a change in that. Tech is maybe overhired because of the COVID pandemic. there was a lot of growth in the tech sector over the last 18 months. Now there's a contraction in that space. So CPG companies like ourselves are hoping that we can attract some talent from tech to work in healthcare and CPG companies versus Facebook or some of the other companies that would be more, I suppose, more well established when it comes to MLOps and data science. So one, put a team together, check, teams in place. But, it's a moving target. You're always looking for the best people to come and do. So what I'm going to mainly focus on today is process, on the journey around changing the conversation with business partners and data science partners and where does MLOps fit? So, well, we just want you to go and scale our products. So they have no idea what that means. They have no concept what that means at all. So it's about taking them on a journey in terms of how do we create AI products versus data science research. We needed a platform, so at Consumer Health in Johnson & Johnson, we actually live on 3 clouds. We live on Google, we live on Azure, we live on AWS. We have compute in all clouds, we have data in all clouds. And we had data science happening in all clouds as well. So you had SageMaker on the go, you had whatever the one in GCP is called, and ML services. So we needed a cloud agnostic platform. So that was the first thing we needed to put together was, could we come up with a standardized cloud agnostic platform that we could set up on any or all of our clouds? So we did a pretty intense, we looked at 2 Gartner Magic Quadrant leaders, and we're finalizing the platform at this point. And obviously, as with any company, culture is huge. No matter what you try and do, if the culture is not right in an organization, you're just fighting a losing battle. So if the culture is not right, and a lot of what I do is just trying to influence people's thought process on how MLOps can benefit the organization. And it's really trying to change the culture of the organization to embrace it. We want to be a digital first company. That's great. It's a great aspiration. But culturally, if you're not already a digitally first company, if you're not born digitally, there's a journey to go on. And have data science being a key enabler of that is an even further journey to go on as well. So for me, data science is pretty straightforward. I've been doing it for 20 years, and it's about solving problems. Someone's got a question, they want to answer the question, you solve the problem. One, do you have data to solve the problem? If not, then it's not a data science problem. If you don't have data, not data science. Sometimes you get people saying to you, I've got a big data problem, can you solve it? I say, yeah, let's have a look. I'll email it across to you. Straight away I say, if you can email it, it's not a big data problem, it's an Excel problem. Maybe we should be looking at a different conversation. So what data science is and what big data is to different people is very, very different. To me, big data is processing models on 200-300 terabytes of data. To other people, it's an Excel spreadsheet. So it's very much about having the right conversation to get the right outcome. But ultimately, data science, what's the question, solve the problem, and then employ data science tools and techniques to do that. So the output from that would generally be models. During that process, what you've identified is what's the data to use, what transformations need to be applied to the data, what are the best model features the model's going to use, what model are you going to use, what are the hyperparameter settings you're going to use in that model, what's the retraining schedule you're going to use in that model, and what does good look like, and then what's the typical accuracy and the score that you're going to get from that model. So data science is very project focused. Can we solve the problem? Engineers, as I've learned particularly over the last 6 months, they think about the world in a very different way. They want to take that light bulb and they want to plug it in. They want to make sure that that light bulb is always on, and you can go and you can visit and you can see the splendor of all the light bulbs like the Eiffel Tower. So they think about things in quite a different way. Even though a lot of the engineers, particularly the ML engineers, they were data scientists because the field is only subdivided in the last 3 years. So you actually have data scientists that want to specialize in creating AI products. But the way they think is quite different to just wanting to solve the problem. They want to make sure the problem is scale, it can be monitored, it's stable, so on and so forth. So the engineering community very much look at integrating these AI problems into scalable solutions. And they very much looking at optimization of infrastructure, optimization of project flows and so on and so forth. So very different thought process. But for me, an AI product, if all you're doing is research, you're a cost center. And if you're a cost center, you've got limited time on this earth because cost centers don't survive. R&D is great, but at some point in time, that R&D has to translate into value. You have to create AI products that somebody can press a button and can make a decision, and that decision either is cost avoidance, promoting, or it's revenue enhancing. If you're not creating value, then you have a very limited shelf life. And a lot of data science, a lot of great data science doesn't go anywhere because the data scientist isn't able to market it beyond, I've solved this great problem. Of course you would want it. Why wouldn't you want it? You're crazy for not wanting it. It's not as easy as that. The hardest part about data science is not the data science piece. It's actually the marketing and the sales job that you have to do to get somebody to want your data science or want your product. So the engineering piece, very much about how do I put that product into practice so somebody can just press the button, or the button is automatically scheduled to press itself, or whatever the business wants. But ultimately, how are you going to extract value from your data science research? And that is an AI product. And without both sides of the coin, it's not legal tender. So, this is the traditional data scientist. And a lot of this has been perpetuated through, Harvard Business Review's sexiest job of the 21st century, data scientists. We're all very special, and hey, who doesn't want to be special? Everybody wants to be special, and we want to be the diamond in any organization, and we want to be the one. Someone was telling me recently that Apple in Cupertino, graduates going to Apple, they all want to start on 6 figures, which is unsustainable regardless of any company in the world. If you're just hiring in 200-300 graduates a year and they all want to start on 6-figure salaries, that's pretty unsustainable. So they're looking to, into Europe and things like that, where you can get graduates that will start on, under 50K a year, whether that's euro or pounds. And ultimately, you're going to get the same bang for your buck, because we don't all need the top 5 MIT graduates or top Stanford graduates to build our models. We need people that really good, really understand what they're doing, and can produce at scale. Some companies then can afford to have those top 5 people, but they're more in a thought leadership capacity. They're not going to be the ones churning out the models day in, day out. So it's great to think that we're special and we have the diamond, but you don't go down the road to Tiffany's and say, hey, give me a raw diamond, I'm going to bring it home and propose to my wife. She wouldn't be all that impressed to say, there's a lump of rock, so, what's this thing? He said, there's a diamond for you. So, well, could you polish it up a bit? So to move from projects to product is very much, okay, you got to get the diamond out of the rock, you got to polish it up, you got to put it in a case, and you got to give us a certificate of authenticity. And that's what the business wants. They want a product that they know. I remember I worked in manufacturing one time, and manufacturing is a very difficult place to try and bring data science onto the ground, because everything is so unique. One manufacturing line could be different to another manufacturing line, despite their best efforts. And the plant manager said to me, I don't care what you call it, if it goes down at 2 o'clock on a Saturday morning, I'm ringing you, and if it doesn't work, you're coming in here to fix it. I said, okay, maybe we're not ready for data science in the manufacturing line just yet, just maybe stick to your ERP systems or whatever. So any business they'd be delighted to have data science and MLOps and all that good stuff. They're delighted to say they have that and promote it and put it in the prospectus to say, yeah, we have all of this stuff. But ultimately, behind closed doors, what's the value? If I press the button doesn't work, and I have learned to make decisions based on that button, who's going to support it? I don't care what you call it behind the background, I want that support. So in Johnson & Johnson, we strive through everything through kind of an agile philosophy and agile mindset. And it works really well in data science. I know there's, some people would say agile in data science because it doesn't always work well together, but I think, you can adopt agile in data science quite well if you make a couple of tweaks to it, which probably isn't what the agile purists want to hear. But if you think about, I was at a talk a couple of years ago, Bill Schmarzer, who's the CTO of Hitachi Vantara, and he said that he would spend one full sprint with his team understanding the question. Because if you don't understand what the question is and you don't know what success looks like or what that button, when it presses, what it's going to do, then everything else you do after that is probably just leading you towards failure. So to have a clear understanding of what the customer actually wants, what problem they're trying to solve for, that's worth more than all the coding and all the scalability and all the data transformations that will happen after that. And it'll make the project a lot quicker. Plus you get that buy-in from the customer, because the customer now has been engaged so intensely up front that they're more inclined to not see data science as the dark arts, as some people think it is. They see it as, okay, it's a science, it's got a process, let's engage in that process. But you got to hook them in day one, because ultimately they're your customer, they'll tell you what the product's meant to do. So one, explore the problem. So kind of break it down into the different personas. You've got your data scientists, you've got your data engineers, you've got your ML engineers, you've got your business intelligence engineers. So depending on how far the project goes, you might start the business opportunity. What's the question you want answered? And then if I answer that question, what value does that give back to the business? Because this stuff isn't easy. You know, it's easy to put a PowerPoint up there, but to actually go and solve data science questions and scale them, that costs money. It costs money on resources, on compute, on data, and on people, and on time. And it's not cheap. So if there's no value in answering the question, then you shouldn't be answering it. Move away, move on to the next question. Because there's plenty of questions. And there's loads of questions that have value. Not all questions have value. Not all questions have equal value. So it's about looking at what's the question to be answered. So very much, if you look at that, probably should be led by your data scientist, working with the business to identify what the question is. Then really clearly define the value proposition. How am I going to turn this statement of a question into a data science use case and that I can solve for? You know, maybe do 1 or 2 sprints. Don't spend forever on it trying to get 99% accuracy, because there's no value in that. Because you may not even be answering the right question. Because a lot of times when you go and you answer a question, you go back to the business and say, hey, the question you asked me, I've answered it. And they go, yeah, we're actually asking you the wrong question. Because they don't really deal in an abstract. When you give them something in front of them and say, there's the answer, they look back and go, okay, now we can see what data science is and we can see what direction you're going in. We're asking the wrong question. So don't spend forever don't let perfection be the enemy of good, or I don't know, I've botched that quote, but you know what I mean. Move on quick, and that's why the agile process as well, don't spend 10 sprints answering the question, spend 2 sprints. Because then if the business identify and say, yeah, we're asking the right question, and you've got an answer to it, then it's about, well, then how would we scale and productize that? Because you're probably going to have to rework that entire solution. And then ultimately monitor and maintenance. So for me, the IP is all front-loaded here. That's where you identify what the problems are, what the use cases are, what the data sources are, what the features are, what the best models are, what the best hyperparameter settings are, how you're going to make this thing work. And then as you move to the right, it just becomes about cost. Running this stuff in an automated fashion, scaling it, productizing it, it's very important. There's not as much IP in that, but it does cost more. So as you move from the left to the right, if there's no value in answering the question, you got to jump off at some point, because it's just getting more and more expensive as time goes on. So if you think in a company, this is what we would strive towards. If you think in a company, a very healthy company with a really good R&D pipeline in data science, you'd have, you know, even if you were to pray to it, if you did 100 projects and 20 of those went into production, that's probably not bad. Market leading would probably be around 40% from research into production. So it's about creating a really stable pipeline. But if all you have is research and nothing's going into production, that is not. And ultimately, your data science team becomes a complete cost center. Data science needs to be seen as a value-driven center. I spent a long time working in supply chains. My PhD is in supply chains. And if you look at Tim Cook from Apple, who was, he's now the CEO of Apple, has been for the last 10 years. He came from supply chain in Apple. And he managed to get that company to think of supply chains as a profit center, a value center, instead of a cost center. Because traditionally, supply chains were always seen as a cost center. Today, data science and MLOps is seen largely as a cost center, because we're not good at promoting the value from AI products and what's the return on investment from the research that we're doing. And data science, like supply chain, has the potential to be a value center, but it's about having the right conversations and getting people to buy into that. So, you've got your research mode, your production mode, and you're going to have different people in different spaces. Ultimately, what I hire for is a team I would say my team is a team of data scientists, that the majority of them specialize in AI production. So they're I suppose what some people would call MLOps engineers. I like to keep it really simple for the business partners. We have a team of data scientists. Some of them specialize in creating AI products. We also embrace this concept of high-performing teams, because that's one of the challenges in a company like Johnson & Johnson is you've got lots of vertical silos. So how do you break those vertical silos for teams to come together to achieve a similar end goal? So if you want to create, instead of having a project focus and you want a product focus, you put together the relevant players to make that product. So again, this is only a snapshot of a team. You would have UI, UX designers, project managers. Depending on the scale of the product, you would have a much bigger team. But for this audience, the key players are your data scientists, your engineers, and your BI engineers. And they're going to play a different role depending on what the project is. So sometimes the project is creating a data engineering pipeline that goes straight to a BI report. So you don't really need an ML engineer there, you don't really need a data scientist there. Or sometimes you create a data science model that creates a new feature, that creates a new data attribute that gets joined into an existing data source that gets put into a BI report. So now everybody's in play there. So it depends on how you're going to consume the output. So for me, I always like to break it down into 3 steps. Any project or product, it's got data, it's got to compute, and you've got to consume it somehow. So from a data perspective, your typical data science project is, okay, we know what the opportunity is, where's the data? Okay, we've identified where the data sources are, so hopefully you might have a data engineer to help you create a pipeline. You don't need a fully fledged pipeline at this point because you're still only in MVP mode. You're only trying to solve the problem. You're not trying to create a scalable product at this point because you don't know if anybody wants it. So what kind of transformations need to be employed with that data that's going to feed the data science models? What kind of model am I going to use? And again, I talked back earlier on about working with the business to clearly articulate the business question. A good data scientist will already have all this figured out in that first sprint, because from talking with the business partner, they'll have identified where the data sources are. They've already thought about what the right model is because they know what the business partner is looking for in terms of a product. And they've already kind of fleshed it out in their head. So when they get to this stage, they're good to go. They can go into sprints and they can keep the business partner engaged and they can execute much faster. So it's very much about working on, defining that use case, doing your exploratory data analysis, and coming up with some models, testing them, constantly engaging with the business. So the crisp DM model is a good model here. And then how does the business want to consume it? Is it going back into a BI report? Is it going to a flat file? However the business want to consume it. Traditionally, the business would think this is it. This is all we need to do. But most people know that this is research. This will get you to an MVP. And then to get into a product, you got to do it all again. Because what you haven't done in the MVP stage is you haven't created pipelines. You might have just taken a dump of data, sat it up and said, have a look, see what you can get out of that, create your model. But to actually create a product, you have to have streaming data. Whether it's a batch job or whether it's a real-time model, data has to be streamed in there on a schedule or real time. And then whatever transformations need to be done, that needs to be monitored to make sure there's no drift on the data. Then your model could be completely redesigned. So we, as part of our evaluation for an AI platform, we gave what I would call the classic data science on steroids product. It's not really a production product because the thing could fall over at any minute. Everyone's afraid to touch it, but it runs and we make decisions based on it today. And it's huge. It runs once a month. It costs tens of thousands of dollars to run it. It processes 200 terabytes of data, 300 terabytes of data every run, and it's unwieldy. So if you look at it from a data science perspective, the data scientist was able to solve the problem and get an answer. From an engineering perspective, it's a completely different challenge because the single biggest bang for your buck is in your data structures. If you have an efficient data structure, the model will run really fast. If you have an inefficient data structure, the model will not run fast. And yes, you can churn through it and compute, and you can pay. But if you have a highly efficient data structure, the model will just fly through it, and then you've really cut down your costs. So I'll give you an example. We had 2 models. One model we looked at, it was a binary classification model that had a single concatenated feature. But when you one-hot encoded that feature, you had 200 billion rows of data and 4,200 binary features. You can imagine in a table, that thing is going to churn through, it takes days. Whereas if you restructure the model as a key value pair sparse matrix representation, the model flies through it. So we were able to cut the costs from about $37,000 down to less than 15. And it all came down to an efficient data structure. Similarly, we got another project where it was just about restructuring the data table into a star schema with a fact dimension data table. Again, one run of the model before the data structure was 200,000. After the data structure was less than 10,000. So the compute doesn't change, but how the compute operates and how the data structure that you have is the key, I believe, to cheap and effective data science. And that's not how data scientists are thinking at the research phase, because they're thinking about what's the right model, what's the right data, what's the right features. But if you go into an AI product, you're looking at data structures, pipelines. How do I get this thing to run really fast, really cheaply, so we get the same value from it, but we pay a fraction to run it? So finally then, it's about how do we capture the value from the AI work that's happening in the new consumer health company. So it's create an AI studio to, one, track all the opportunities. Because you get people say, I've got a data science opportunity for you. First thing you got to do is you just maybe sit with them, because it may not be a data science opportunity. They may not have any data. If there's no data, it can't be data science. Or they may not have enough data, but you can tell them, look, this is the kind of data you would need, come back in 6, 12 months, always give them something back. But ultimately, to see if it's a real opportunity, at this point, is a go, no-go? Do you want to proceed, or do you say, look, you're not ready to kind of come into this process just yet? So one of the things we're doing is we'll generate a project ID, but this project ID will now live with that project throughout its entire life cycle. Every resource that's consumed by that project will be tagged with a project ID. That way, then, we can just track the costs associated with it. Because right now, we're finding it very difficult to track the cost, particularly across different cloud structures. Whereas if we have a cloud-agnostic AI platform that we can tag every project with a project ID, then we have a better idea to say, well, the cost associated with that project was X. And the real winner here is for our CIO to be able to turn around and say, how much am I spending on AI? And how much of that is actually going into production? So what's my research pipeline like? What's my production pipeline like? And you get to push back a bit then and say, this is not a healthy pipeline, or this is a really healthy pipeline. But right now in the dark, it's very, very hard to answer those questions. And people like that, particularly in data science. We like to obfuscate things and hide behind things because, having to turn around to someone and say, the output from this model is X, and the value you're going to get from it is Y, so your return on investment is Z. That's a difficult conversation. Most people kind of shy away from those conversations. So if you try and kind of put it front and center and say, we want data science and MLOps to be a value center, not a cost center, then you've got to put your neck on the line and say the value from this, if I sell this to the business, then they're going to get X from it. And they have to sign up to it as well. So not everything is going to go in from research into production. And ultimately, it's about, if I'm going to run this thing 24/7, I'm going to support it, what value am I going to get? What's the ROI from it? Because if I don't have any value in it, I shouldn't be doing it. I'll move on to the next, because there's no shortage of questions. There's no shortage of opportunities to employ data science and MLOps. But it's about finding the ones that actually return value to ensure that you've got a healthy pipeline of research behind you. So that's kind of the first 6 months. Again, it's very much around conversations with people, changing the narrative about how they think about data science, think about AI products, think about MLOps. So what's the next 6 months look like? Well, one, onboarding the new platform across 1 or 2 of the clouds, migrating existing data science work that we have in our existing native cloud structures onto the new platform. This is a huge piece of work here, because what we have is we've got a lot of data science that says it's production ready. It's not production ready. It is being held together by Band-Aids and sticky tape. So they need to be migrated into a proper MLOps or AI product pipeline where they can be supported and monitored. And there's a cost associated with that. And if we keep going down that road, data science is going to be very, very expensive, because for every data science project you have, you've now got an MLOps project that says, oh yeah, everything that you've done has to be rewritten. It's all junk. So I can use your model and I know what your features are, and I'll take the basics of what you gave me, but everything else has to be rewritten. That's a very expensive model. So we need to say, okay, well, we are where we are, and this is what we need to get to. We need to get to a right first time model where the data scientists recognize that during the research phase, do 1 or 2 sprints, and then recognize that the data structures may not be optimal if you're moving to production. So it's about changing the narrative from just having research, chucking it over the wall to someone else and making it their problem. Because ultimately, from a CIO's perspective, it's all part of the same cost center, so you all get lumped in together. So you may as well try and reduce the cost to provision these models, and that way then your MLOps team can work more on, instead of having 1-to-1, 1 data science model per 1 MLOps engineer, they might be able to look at 10, and more in a supportive role to say, have you looked at these data structures? Have you looked at these model design patterns? And last but not least, I always like this quote from Peter Drucker: if the culture in your organization is not right, everything else I just said is a load of shite. Won't happen. Because if the culture is not right in an organization, they can talk about PowerPoints all day long, but if they're not willing to embrace the change that's required and the cost associated with that, then nothing happens. Thank you very much.